Hey everyone, welcome back to the channel. Today, we're diving into one of the most mysterious and mind-blowing concepts in all of science, entropy. You might have heard people say entropy is disorder, or that it's the reason the universe is falling apart. But what does that really mean? And how does it affect our everyday lives? Well, buckle up, because by the end of this video, you'll understand entropy not just as a science term, but as a way to look at the universe, time, and even life itself. What is entropy? Imagine a clean bedroom. Everything is folded, books are on shelves, and it looks like something out of a catalog. That's a state of low entropy. Things are ordered. Now imagine you wake up, toss clothes on the floor, scatter some books around. Suddenly, the room looks lived in. That's higher entropy, more disorder. But here's the interesting part. It's much easier for your room to get messy than to get clean, right? That's the essence of entropy. In physics, entropy is a measure of how spread out or random a system is. It's like nature has a preference, and that preference is for things to go from order to disorder. The second law of thermodynamics. There's a very famous rule in physics called the second law of thermodynamics. It says, in an isolated system, entropy will never decrease. It will either stay the same or increase. Let's say that again. Entropy never goes down in a closed system. It either stays the same or gets worse. This law explains so many things we see every day. Why hot coffee cools down, why ice melts, why you can't unbreak an egg, why your room doesn't clean itself. Entropy always increases unless you do work to fight it. Entropy and energy. So where does energy fit into all this? Entropy isn't just about messiness. It's about how energy is distributed in a system. Let's take an example. Imagine you have a box with a bunch of gas particles inside. At first, all the gas is squished into one corner, neat and organized. But over time, the gas spreads out to fill the entire box. Why? Because there are way more possible ways for the gas to be spread out than to be packed into one corner. And here's the key. More possible arrangements means more entropy. So the gas naturally moves toward the more probable state, the higher entropy state, without any outside force. Boltzmann's brain. Now let's bring in a legendary physicist, Ludwig Boltzmann. Boltzmann gave us a powerful formula to understand entropy. Equals ln. Oh, S equals KLN omega. Whoa, that looks scary, right? Don't worry, we'll simplify. S is entropy. K is a constant. Oh, omega is the number of ways you can arrange the system, the number of microstates. So this tells us, the more ways a system can be arranged while still looking the same on the outside, the higher its entropy. Your messy room? Millions of ways to be messy. Your clean room? Only a few. That's why the universe trends toward messiness, because it's more statistically likely. Entropy in real life. Let's make this super real. Ice cube melting ice. Put ice in a warm drink. The ice absorbs heat and melts. The water molecules go from solid, ordered, to liquid, disordered. Entropy increases. Hot beverage cooling coffee. Hot coffee in a cool room loses heat to the air. The heat energy spreads out, entropy increases. Egg breaking an egg. Crack an egg and spill it. Can you unbreak it? Nope. That would be reversing entropy, and that's very unlikely. The human body. Even your body obeys entropy. Every time you move, eat, or breathe, your cells are creating disorder in the environment, heat, waste, etc. We stay alive by burning energy, and that creates entropy. Life is basically a local battle against entropy, paid for by releasing energy into the surroundings. Time and the arrow of entropy. Here's something really deep. Entropy is one of the few things in physics that gives time a direction. Most laws of physics, like gravity or motion, don't care if time moves forward or backward. But entropy does. You can't untoast bread. You can't unmix cream from your coffee. You can't unpop popcorn. That's why we remember the past but not the future. That's why we age. That's why the universe moves forward in time. Entropy is the arrow of time. Entropy in the universe. Now let's zoom out, way out. The universe started in a state of low entropy. The Big Bang was incredibly hot, dense, and ordered. Since then, entropy has been increasing. Stars burn out, galaxies spread apart, energy becomes more and more diffuse. Eventually, scientists believe the universe might end in a state called heat death, where everything is so spread out and disordered that no energy can be used to do anything useful. Total entropy. Depressing? Maybe. But it's also kind of beautiful. We're here in a brief window of time, surfing this wave of low entropy order. Can entropy be reversed? Here's a fun question. Can we ever decrease entropy? Short answer, yes, locally. Every time you clean your room, you're decreasing entropy in that space. But, and this is key, you're increasing entropy elsewhere by burning calories, sweating, using electricity, and so on. So entropy can go down in one part of the system, but the total entropy always goes up. You can think of it like this. Fun facts and myths. Let's bust a few myths and share some cool facts. White heavy checkmark myth. Entropy equals chaos. Magnifying glass tilted left truth. Entropy is about probability, not necessarily messiness. White heavy checkmark myth. Entropy is evil or destructive. Magnifying glass tilted left truth. Entropy is natural. It makes the universe dynamic and interesting. White heavy checkmark myth. Entropy means everything falls apart. Magnifying glass tilted left truth. It just means systems evolve toward the most probable arrangement. Fun fact, black holes are the most entropic objects in the universe. Their entropy is related to the area of their event horizon, not their volume. So what is entropy? It's not just a science term, it's a law of reality. It explains why things happen, why they fall apart, and why time moves forward. Entropy is the story of energy, of life, of the universe itself. Next time your coffee gets cold or your room gets messy, just smile. It's not laziness, it's physics. Thanks for watching. Friends, if you enjoyed this video, give it a thumbs up, share it with a curious friend, and let us know in the comments. Puzzle piece, what's the most mind-blowing thing you learned about entropy? Don't forget to